Super, weiter geht's.
All right, let's continue with Oscar.
Ich darf um Aufmerksamkeit und Ruhe bitten, weil es kommt ein sehr spannendes
Please
Thema.
be quiet and give us all your attention. This is going to be a
Es
very
ist wieder
interesting topic.
eine kleine
And
Technologievorschau, was wir
this
gerade
is a little bit of a
machen.
preview what's going to happen
Ist etwas mit ein
today.
bisschen mehr Substanz, als
And it
das,
has
was
a
ich
little bit more
gestern vorgestellt habe.
substance than what I introduced yesterday.
Titel ist
And
Capacity
the title
Management.
is
Das war mal
Capacity
der
Management.
Ausgangspunkt,
That
aber
was
ich
where we
glaube,
started,
man
but
kann
I
es so
do
sagen, dass wir da
think
deutlich mehr
that we
machen.
can say that we're doing
Letztlich
a
geht es
lot
eigentlich
more
darum,
than
dass wir
that.
aus diesen
Overall,
ganzen
it's really about
Messdaten, die wir haben,
really
viel mehr
getting all the
rausholen,
data
als
that
nur
we
die
have and getting
Zeitreihe
everything
anzuzeigen.
out of it
Und da hat der
than
Oskar
just a
zwei sehr, sehr
timeline. And
interessante
Aska
Dinge
has a
gemacht,
couple
auch so mathematisch
very
auch sehr
different
fundiert.
things he's done.
Und das wird er euch jetzt vorstellen.
And yeah,
Und
he's going to
los
introduce
geht's.
all of that. So we're very much looking forward to that. Yeah, hi, good morning. All right, like I said, this is a technology preview. It's not implemented in Checkmk yet, but the idea is to just introduce it to you and then also have a discussion with you towards the end and just talk to you, learn what you think is interesting, what you're hoping for, what you need right away, and so on. So all the things that you're hoping for, that's what we can discuss later on. Okay, so in our program, Houston, do we have a problem? Well, of course, we're monitoring our system, and if everything works well, then everything's green, but the idea is that we can still improve something. And can we also, for example, do we know that the system is working well or not? And can we also get additional information from our monitoring data? What do we think capacity management is? What do we want to see? We have a couple standalone demos, and then at the end of the day, we can have a discussion with you. All right, now, do we have a problem? That's the big question. And our main responsibility is to make sure that the system runs well and that it just runs as smoothly as possible. And of course, it can't be too high because that's going to cause too many problems. If it's too low, it's going to be too expensive. So it's really about performance and how much you're going to need it for. Okay, Checkmk, we use that to do monitoring. We have business intelligence that also helps us. What could go wrong? And all we want is a smooth running system that our customers can use. And if we use combined graphs, we can also look for interdependencies, but we just want more than that. And the idea is to really make it where we can see our data as well as possible. We really don't want big statistics or anything like that. We don't want that in our system. The sysadmin should be able to just see everything they need to and be able to work with that. Okay, so capacity management is what we're going to talk about today, and what do I want to achieve? I want to control my resource utilization, and of course I want to balance that across the whole infrastructure. How can I see that, and how can I do that? Well, for this demo, I don't have access to a direct monitoring system. This is just simulated data. But I would like for you to imagine that we have this file system tool, and I have my hosts right here, and I'm interested in these hosts on two different metrics: disk IO write, information per second, and this graph right here that you see. I don't have any site system anymore, but what I do have is I have all my hosts, these metrics right here. And the horizontal axis, we have the disk IO operations, and the vertical axis, that's the number of hosts. And what I can see here is, okay, generally all my systems are in the disk IO, so they're very close together, very evenly distributed. And if I look at the file system usage in gigabytes, so what we have right here, that's the metrics, and then the vertical axis is the number of hosts again. I can see that, okay, I have somebody that's really not in that group anymore. This host right here is really not utilized by the file system. And what's nice about that is that I can always look at the histogram and really look at this individual piece. You can see it in that table. That's the host number 15, and you can also see the correlation in the disk I/O. So it works a lot. It does. And it's at least the average. So that's the first step. How can I correct that? How can I choose something else? And it's always going to be a table, and you can just see how that correlates to the other metrics. And that's going to help you see the correlation between these two metrics, and also why is it important to really analyze this outsider. Okay, good. Now I have a second view of correlations that you could use. Okay. So now we do the monitoring of an application, and what we see here is logged users, and I want to compare that to the roam usage of my system. So each point, or each little dot you see right here, is a timestamp, and this timestamp means that we here have 100 logged users and 2.5 gigabytes. And now I see a correlation, so we have two different branches right here, and you can just see the utilization of your system. High utilization and low utilization. You can always compare, okay, I need 5 gigabytes RAM if I have about 150 or 120 users. I also hope in the future I'm going to be able to see a graph and just see the ratio of utilization. Okay. So this is just correlation. So now if you want to work on data from the past, you can do even more. You can have a model and just see the future. It's very important in order to understand this capacity requirement. You need to understand how they change over time, and then also just make a prediction for the future. So am I going to need a bigger infrastructure in the future, and so on. How do we do that? Okay, you can easily do that. You can just have a linear extrapolation, and you can just say, yes, probably in the future my system is going to be utilized like this or like that, and I'm going to need more infrastructure. Lots of softwares do that, but I'm losing two things here. For example, capturing cyclicality of usage is difficult. So what do we want to do now? Well, we just want to do a little bit more. We have this generalized additive model that we built, and it's pretty nice. What's nice about the additive model is that you just choose portions that describe my problem. Our model is made of two things, so just a general trend. So that's just a linear regression that we've had from before, from our program. And then we also want to know the oscillations. That's what we want to describe. So that's just how it's changing on a daily basis. And that's a pretty stable procedure. So if you have a curve like that, or a wave, for example, so you can change it like that, and that's what we have. So it's a big topic for different things, and it's generally used in order to decompose a signal into its frequencies, and we can also just recognize patterns, cyclical patterns. And this is what we see right here. So we have the signal, and we can use waves for that. It's great for us, for our use case, definitely. And the procedure is also very stable. It's easy, stable, and it's a projection really, and we have a good convergence of that procedure, and we really don't have to work on our data all that much. So what does that look like? This picture shows you the timeline for several different years, and the y-axis is a metrics that we're following. So those are the black dots you see here. And this blue line is what we're looking for. And we also have a confidence interval, which is light blue. Of course, it's not super perfect. You can see that there are some outsiders here. There's some changes as well. And what's happening is what I already said. So we have a linear migration piecewise. So if the trend is changing in that timeline, then there are certain changes that come with it, and then within this year, for example, we can see that there is higher usage, lower usage in specific months, and also within 1 week. We can also see that there is higher usage on certain days as well. Yeah, and if you now add all of this up, then we see our fit model. Okay, now let's take another look. What we see here is monitoring data of a simple simulation, and you would be able to see that with combined graphs. So we have time series in our graphs. So our application started on March 1st up until the end of the month. So this plot, I'm going to compare the monitoring of logged in users. So of course, it's about this simulation. So I have more users if everything works well. And each user has a daily usage. And of course, they're not working all day. And they prefer some specific time to use the system. So usually 12 to 6 or 7 in the evening. And what we see down here, that's the CPU use. So that's the CPU utilization course. And we can also see that some are at 70% usage of the system. Then we have RAM usage, and then we also have the response time of our application in seconds. And we want to keep that as low as possible, so 300 milliseconds. Yeah, so it looks really good. Our system has 2 cores in the simulation and 16 gigabytes RAM. And I'm now going to simulate the past 4 weeks. Not a lot has changed in terms of response time. We can see that our users, well, we can see that we have more users now. There's more utilization of the system. And now we want to know, what is it going to be like in the next 4 weeks? And in order to do that, we have a prediction tool. Prediction engine. So I can just choose a random metric to do that. CPU utilization, for example, and then I can say, okay, when do I want the data collection to start? March 1st. And I want a prediction until the end of May. So I can just do make prediction. That takes a while. And I also need some indication that it's in process. That's being processed right now. Okay. So this graph is, well, it's a lot, but I'm going to explain to you what it is step by step. So the horizontal axis till the timeline, vertical is the metrics that we chose. So CPU utilization. We also had data from March 1st up until the end of April That's the black spikes you see here. And yeah, so we can also just see the linear trend. And this vertical red line shows you where the trend changed a little bit. That's automatically recognized, but the trend is always corresponding to the average utilization. In addition to that, since we have this series right here, these blue curves that you see right here, they're trying to get closer to the data, and we have information about the periodic process and also the growth. Deviations are increasing with this trend. And since a prediction is not good enough, if we don't have our confidence interval, this yellow portion right here, that's at 90%, and it's supposed to contain all data. And it shows you where the data is, and this is also our confidence interval for the prediction. So I can see that for July 1st, my infrastructure is supposed to grow, so 2.5 core systems if my usage needs to be under control. Yeah. So this is just a simple model, but using that you can have better predictions. You can also tell management you need more resources, for example, because of that prediction. And what's next? Well, we have a couple more ideas, and we also want to do more for the time series. I'm going to show you a picture about that later. Correlations between metrics. I already showed you that. And if I want to compare two metrics, for example, anomaly identification, that is also an idea we have. I'm not sure if you think that's going to be helpful or not, but I really want to hear your opinions. What do you think? And this last graph right here is an analysis. So if I have my timeline, I have a response time, and it's difficult to say, yes, my application is this fast or that fast. And if I have this overview, I can say, okay, this is my response time, and I can say, okay, within these 300 milliseconds, I have 90% of my users or requests already there. And in a second, it's 79%, and all my requests are always responded to within 3.5 seconds. That's extremely important, especially if you want to see other metrics as well. Yeah. Okay, that's it. Thank you very much.
Are there any questions? Just a short question. What versions will that be in? Maybe not 1.6. It's a standalone prototype, and I'm trying to estimate the challenge behind it. How difficult will it be to integrate in our system? Maybe you have a feature that you really need really quickly. Maybe later. I've got two questions. First one would be, do you envision a feature where I can do something like a release comparison, or have two annotations, 2 points in my graph, and can say this was release A, and here we switch to release B, and how did CPU something, some value, how did it change, so I can make a comparison. Because right now I only have the possibility to set a point in the graph and can say something happened there. Yeah, I see where you're going. The idea is, at least with these histograms, from my I can choose from my time windows. Like before the first release, I wanted aggregation, and then you can get a histogram. You can get usage or load or cumulative, make a snapshot, and then you just open a second time window and do the same steps basically. I mean, this is already quite useful. You can do that. And what was the second question? Where is the sticker for anomaly detection? Well, many people say we need that. It will take a while because anomaly detection means that all sites need to go through the fit. How much would be contained in the model, and then you can have a subtraction. This one was far off, and why is it? This is complex and it will take a while to implement. But if you want that, then we can do it. Any further questions?
Gut.
Okay.
Dann vielen Dank, Oskar.
Thank you, Oskar. Thank you.